my screen, if you are able to see the white, just a second, if you are able to see the whiteboard on which fundamentals of dynamics has been written, then raise your hand so that I can see. Just yeah, okay. Okay, so let's start. So this is the fundamentals of dynamics, and it was the first class was supposed to be on 25th, but due to some circumstances, we couldn't take that class on that day. So let's start today. So fundamentals of dynamics. So the first thing which will come to your mind is dynamics. So we often talk about this dynamics. We say some person has a very dynamic personality, or we say that this object is dynamic in nature, all these things. So whenever we say like this, we in our mind, we think that something is changing. It is not constant. And the particular parameter with which we are comparing these changes is the time. With time, for example, if we say a person has a dynamic personality, by this we mean that he knows how to handle different situations at different times. Okay, so similarly, if we say that the object is dynamic, we basically mean that the object is changing something. Maybe it is changing the temperature or color or the behavior or the strength. So all of these things, we say that the object is changing with time. So this dynamics then somehow is related to the time. Okay, so but in this particular class, we will be dealing with the dynamics of these objects in itself. So if we define the dynamics from our perspective, so we can say, okay, let me write down. So we can say by dynamics, we mean finding relations between force and motion. Okay, so basically we have some forces, maybe electrical force, we have gravitational force, and because of the consequence of these forces acting on some body, the body has some motion. So we want to find relation between these forces and the motion. For example, we apply some force and how the particle is going to have its motion. Okay, so the general, so this today's class is just an introductory class, and I know it will be very hard for me because I am not good at introducing things, but I will do my best. So to introduce this class so that you will get a glimpse what we are going to do maybe in coming 1 or 2 months, and what will be the end result for you. So basically we will be the goal of this class. So what will be the goal of this course is that if we are given the position at any particular instant of time, say t naught, so can we find the trajectory of the body? That is, that at a particular instant of time, we are given that the position of the body. Now, can you tell me the position of this particle at some time t? That is what we mean by the trajectory. Trajectory is nothing but the position at a history of the position versus the time. Okay, so the basic idea is that so we have to build this thing that somehow we should be able to predict the trajectory of the body. This is not only the case with the this physical things only. We can have, for example, at a given instant of time, there is some economy of the state or the country, and we want to predict what will be the economy of the country in the coming time. This is the population of the country, what will be the population in the coming time. So we will build a general perspective that how these dynamics, how we can solve these dynamic things or dynamic problems that which are changing with the time. So let's get started with some, because I know you all like the graphs and other stuff. So let's take an example and try to understand what we are trying to understand. Okay, so let us take this example that this is x-axis and this is y-axis, and let's suppose that this is the collection of the points. This curve is the collection of the points. Just wait a minute. So just raise hand if I am still audible or something is wrong there. Okay, so I am clear. Okay, so this is x-axis and this is y-axis, and so this is basically the collection of points, and this collection of points follows some particular rule, that is this rule. So we say that all these points follow this rule, that is if you take any point, so x and y, so there will be this relation which will be satisfied. Okay, so we call that this curve represents y equal to f of x. Okay, so let's take some point x naught. Oh no, I have taken the point at wrong position because this will not serve my purpose. But I want to explain. Let me take different point. Okay, so let us take this point. So this is some x naught point. Okay, this is x-axis. I can take any point. I'm taking x naught point because maybe, for example, at this time there is time t naught. And corresponding to this x naught, I know that this function has a value y naught. So now the question is that let's think that we know this y naught and we know this x naught, and after some time or the change in some x by delta x, okay, can we predict or can we find the value of y? Let's call this value as x1 and let's call this value as y1. So what is given? So let me write down here. So given we have x naught and we have y naught, and after some time, after some change in x, that is x1 new x, so this is given. Okay, can we find, this is also given, can we find what is y1? So this is our question. Okay, so we can do it in various ways, but I know the way you have been doing it is like this. So we can find y1 minus y naught upon x1 minus x naught, which is nothing but uh, okay, delta y upon delta x. Okay, so this is the exact relation which we have. So we can further take it and say that y1 minus y naught is equal to delta y upon delta x, and this is x1 minus x naught. And okay, so this is the exact relation, isn't it? I think so. There is nothing. I have taken the approximation. Okay. Okay. So let us now assume that this delta x tends to 0. So when I take this delta x tends to 0, we can say that this delta y upon delta x is equal to dy upon dx. So basically, this limit has to tend to 0. Okay. Delta x should tend to 0. Then we can write this equality. But in reality, we can't do this. We can't take delta x to 0. So we can write y minus y naught equal to is equal to dy upon dx into x1 minus x naught. Okay, and see that we are evaluating this limit at x naught. Okay, see, when I am saying that this delta x is tending to 0, basically x1 is tending to x naught. So I am evaluating this thing at this x naught. Okay, so anybody having any question till now, please raise the hand if you have any question. Anybody having any question? Silly questions are also allowed. You need not to get a very decent question so that I can praise you. Okay. So what we have got is, so we have got y is equal to y naught plus dy by dx at x naught into x1 minus x naught. So we have got this thing. Now if you go back and see this equation, see this figure. So we were trying to, so basically we were given x naught, so this is given, and we were given y naught, so this is also given, and we were given x1, which is here, and we were asked to find out this y, that is y1. So this is y1 here. Okay, we were asked to find this y1. And we have somehow managed to find this y1 in terms of the given things, but the only thing which is unknown is dy by dx. So we don't know what is this derivative at x naught. So if we are given this, we can find y1. So let's assume at this point of time that we know this derivative at x naught. So if we are given this derivative at x naught, so we can find the y1. Okay, so this is how we solve this problem. So now we have something y which is changing with x. We are given its values at some instant, and there is a change in the value of x. So we can find the new value of y1 corresponding to the new value of x1. But only thing we should know is that what is this dy upon dx? And this dy upon dx is basically, this is basically what? This is df upon dx. Okay, because along this curve, this y is nothing but f, that is function. So basically this is function df upon dx. Okay, evaluated at x naught. So this is the thing which we should know. If we are given with this function, we can predict the value of this x, y at any new instant of x. Okay. So can anybody among you tell me, so what this equation is basically? Have you seen this equation before? Don't be so shy. I know that you are, आप लोग डरते नहीं हैं, तो क्वेश्चन पूछो, ठीक है, या जो भी है, so that this is an interactive class. So have you seen this equation before, or can you make any similarity between this equation and what you know? Yeah, anybody? Backbenchers, you are the brilliant minds, I know. Okay. Okay, so let me explain what this equation is. So if you are at this position and you want to find the new position, so basically this dy upon dx represent the tangent at this point going to the next point. But the thing is that, okay, let me redraw the picture and zoom it out what I am saying. So this was our function and this was our x naught and this was our x1 and this was y naught and this was y1. So, so what we basically do, we take a tangent from this point to this curve, we take a tangent. Okay, so this is a tangent, this straight line. And we predict the new value y1 by saying that between these 2 points x0 and x1, this function linearly varies. Sorry. So we assume that this function linearly varies from this point to this point, but you can see that this function need not to vary linearly from this point to the next point. So obviously this is not the exact value. That is why I have put this inequality sign here. Okay. So this is not the exact value of this function. This is just the approximation. The more these so the more the points are closer to each other. Excuse me for 1 minute. Okay, sorry. So I was saying that we take the linear variation of this function from this point to this point, but this linear variation is not guaranteed. And it is obvious that this function may vary from this point to this point in some non-linear fashion. Then this equation will not be. So that an equation, I think I have. Where I have written that. Okay. Uh, okay. So what we will do. Basically, this is our function, and we know value of the function at x naught. And by using this equation, we can find the value at x1 by using this equation. Okay, we can use this equation to find what is the value of function at x1. Okay, so this is the value at x1. Similarly, you can take another point x2. You can get y2. Why? Because now you have this formula, because this formula is saying you that if you know some point y naught x naught, you can find the next value of the function, that is y2. Okay, so by same procedure, what y2 will be equal to? So y2 should be equal to y1, that is previous point, dy by dx, but this time this will be evaluated at x1. Okay, x2 minus x1. Similarly, you can evaluate for x3, you will get y3. Okay, so on. Xn minus 1, yn minus 1, xn, and yn. Okay, so what will be yn equal to? So in the similar fashion, I can write, you can check it at your places. I can write yn plus 1 will be equal to yn, that is previous point, dy upon dx, that is derivative, but evaluated at xn, and this delta x. This, see, if I am taking equal steps, that is x1 minus x naught is delta x, x2 minus x1 is also delta x, x3 minus x, this is also delta. Similarly, this basically was xn plus 1 minus xn. Okay, but I call this change of x in x as delta x. Okay, so this is our general equation. So this is not a, so this is very important equation which we have. So let us see, and let me tell you that this is known as Euler's method of integration. So basically you are integrating something, you have, so what is known? So from all these discussions, we are taking something that this is known, that this, the thing is dy upon dx or df upon dx. At every point that is x naught, we know what is dy upon dx. X1, we know what is dy by dx. At xn, we know what is dy by dx, what is its value. So if we are given that information, only then we can use these kind of small steps to get the next value of y. And when we will evaluate these at every end point of x, then we know what is x1, what is y1, what is x2, and what is y2. So we will get a set of values like this. So again, let me tell you, if anybody has any doubt or question, he can raise the hand. See, this is the general overview of the class. So you need not understand everything. Okay, these things will get repeated every time, but you should get an overview of the class, that what we will be doing throughout this course. Okay, so now we have got set of pointers, that is x naught, y naught. Then we have got x1, y1. Then there may be x2, y2. So on, we have got n number of points, and here is x and yn. So when you have got n number of points, then you can join these points and you will get this. You will get this curve. So you have got the trajectory. So this was our goal. We were looking. So our goal was to find the trajectory of the body, and we have got the trajectory of the body. But some of you may be wondering that what nonsense he is doing. He is already given a trajectory, and now he is saying to break it down, get some discrete points, and then again joining these points. So why he is doing like this? The thing is that whatever I have plotted in my first drawing, that curve, actually that is not available to us. If that is available to us, then there is no fun of doing all these things. Okay, so that only information given to us is that the point, that the particle is at some initial point x naught, y naught. After that, we don't know what will be the trajectory of the particle. Okay, that was the information. This was just to show you how the things work. But actually, we will be given that this is the initial time the particle is at. And the second information will be that dy by dx at every point will be given. So you might also wonder that if we don't know the function, how can we find the derivative? This is the another doubt which may arise in your heads. So yeah, this is a genuine doubt. So I am again and again saying that I know what is dy by dx, okay, at every point. So let me take an example and show you what I want to point out. So let us take this curve. So this is x-axis and this is y-axis, and this curve represents y equal to x square. Okay, so let me take this point as x1 and the corresponding will be y1. So what do I mean by dy by dx? So for this curve, you can calculate dy upon dx evaluated at x1 will be equal to d by dx of what is y? It is x square. Now we have to evaluate at x1. Okay, go ahead and d by dx of x square is nothing but 2x, and we have to evaluate at x1, and this is equal to 2 times put the value of x1, so this is x1. So what is the dy by dx at this point? It is 2 times what is the x coordinate. So you will draw a tangent here. Okay, the slope tan of theta will be equal to 2 times this x1. This is what we mean by the dy by dx at some point. So you are given this function, you can find this derivative at that particular instant, at that point. Okay, so but the first thing is that you know this function x y equal to x square. But what I'm telling you that we don't know this curve. We don't, because if we know, then we are done. Our point is that we want to find this trajectory. For example, if our particle is here and we know that it is going on this curve, that we know its trajectory, then there is no fun. But what I am saying is that we only know that the particle is here and we don't know this trajectory. But what we know is that initially it is here, and for all other times we know dy upon dx at that x. We know this information. So does it look something strange? Yeah. Anybody among you who sees any strangeness in this thing that I am saying? So I have taken two things. One is that if we are given some function, we can find its derivative at every point. Like we have this dy upon dx, y equal to x square. I can find derivative at any point. But the second thing is that I am saying that I don't know what is the trajectory. What is this function y equal to f of x? I don't know this function. Okay, I need to find this function, but yet I want to find the trajectory. That is that function I need to calculate. So how can I calculate? So I am saying that I know the initial point where it is. The second point is that I know the derivative of the function. Does it seem strange to you? Anybody? I don't know the trajectory. How can I find the slope? Anybody at least raise your hands to say, to admit that, yeah, we are confused. We don't know. At least this thing you can say. Okay, so one of you raised the hand. I appreciate his boldness and braveness. Okay, so unless and until you know, you don't understand the seriousness of this problem, you can't solve the problem. Or if you solve the problem, you can't appreciate the solution. So I am again repeating this thing, that we have a particle and we are given that this particle is at some initial position, and we are also given that the way it will. Okay, is anything wrong? Someone has shifted its position. Any question? Okay. So I was saying that the seriousness lies that we know the initial position of the particle, and we know that whatever trajectory it will follow, the derivative of that trajectory will be this. We know that. Okay, this is something which your brain will not interpret at the first time. Why? Because if we don't know the trajectory, how can we find its derivative? Here is what was the breakthrough given by the Newton. So now you should appreciate the Newton's laws of mechanics. Even though we don't know the trajectories, yet we can define the derivative of those trajectories. So the whole in our whole course, throughout the course, our main purpose will be to find this dy by dx. Okay, so the next point will be that we will use the laws of mechanics to find out these derivatives, that is dy upon dx. Although we don't know what trajectory it will follow, but we will be sure enough to say that this is the derivative of the trajectory it will follow, and it will directly come from the Newton's laws of mechanics, which you have been doing from your high schools. Okay, but you never appreciate the thing because you don't know how these will, or maybe some of you know, apart from doing the theoretical things, you don't know how these mathematically help us to solve the things. Okay. So what next? So, okay, so the thing is that we will be using the Newton's laws. So till this point, you should be now. The thing is that, okay, let me explain one more thing here. So you are in third semester, and you will also be doing some mathematics course, isn't it? Anybody raise your hand if you are doing the mathematics course? You don't have mathematics course in this semester, in previous semester? Was there any mathematical course in previous semester? Have you learned about Taylor's series? If you don't remember, don't worry, but say that we have gone through the Taylor series. Have you gone through Taylor series? Okay. At that time, you might not appreciate what Taylor has done, but let me remind you that Taylor series and see how fascinating series that is. Okay. So now let me take you back to Taylor series. So Taylor says that if we have any function y of x, this y of x is equal to y of xn, that is evaluated at some point, at some xn point. If you want to find the value of function at some x, find the value of y at some given point xn plus x minus xn. Oh, sorry, something bad happened. Okay, so Taylor says that if something has happened wrong, I think I should reconnect my. So till I reconnect my whiteboard, if you have any doubt, in your mind, you can raise. I will reconnect my whiteboard because some problem has occurred in between. It happens sometimes. You can't predict this thing. So yeah, if you have any doubt, come on the microphone and tell me that I have this doubt. Problem is still persisting. Let us open the new whiteboard. I think that might solve the problem. So I was saying that according to the Taylor's theorem, y of x is equal to y of xn plus x minus xn dy by dx evaluated at xn plus x minus xn whole square upon 2 factorial d2y upon dx xn. Okay, and so on. I can take this up to so many terms. But see, if I truncate all these, so when can I truncate the things? So it depends upon your x minus xn, how far you are going to. So this is your x-axis and this is your y-axis and this is your function y of x, okay, or f of x, whatever you may call. And this is your xn, and this is your x. So what Taylor is saying you that if you want to evaluate the function here, you want to find y of x. Don't evaluate it here, evaluate it here, y of xn. And if you want to find this value will be equal to what is the value here plus what is this change, that is x minus xn. Whatever is this change, I will call it as delta x. Multiple it with first derivative plus take the second derivative, take the third derivative, take the fourth derivative, take n derivatives. If you take n derivatives and multiple it what Taylor is saying that multiple it in this fashion, you will exactly get this y of x. Whatever is the actual value there, you will get by this equation. But this is not a practical thing, okay? Why this is not a practical thing? It is because that we can't go on with the infinite series. We can't find the so many number of derivatives. So what is the next solution? Next solution is take this point closer, closer, closer. So that this x minus xn is very small. So when this x minus xn is very small, these square terms, cube terms, which are multiplying with the higher order terms, those will get very insignificant because those terms will be very, very, very small as compared to this first term. Okay, so this is the exact relation. Okay, there is equality, but if you assume that x minus xn is very small, then you can neglect these higher order terms. I told you why we can neglect these terms. So I can write y of x equal to y of xn plus what is this? This is delta x. And what is this? This is dy upon dx. evaluated at xn. But this is not the exact relation. This is just approximation. And approximation, because we have neglected higher order terms, there is some error, small error, okay, which will be there. If we neglect this error, then this relation will not be the exact one, it will be the approximate one. And this is the same equation here, what we have derived, y equal to yn plus dy by dx. So this is actually the Taylor's first order approximation to the to our equation. So now you can say, so why are we doing this? Okay, so why are we doing this is because, okay, let us see this equation. Why are we doing this? It is because we know that our particle may be a ball, maybe a projectile, whatever you may call it. We know that it is here and we want to simulate it in MATLAB or something. We want to simulate it that what will be the trajectory. So in MATLAB, you will have this x0, x1, x2, x3. We will see in coming lectures how we can simulate our this particle dynamics in the MATLAB. Okay, this is the whole purpose of the class. So you will get an equation like this, and then what will you do? You will take this into MATLAB, code things, and get the equations done. Okay, so but the general idea is that we have to basically get this dy by dx. It is very important for us. So the next thing is that we need to get this dy by dx. Okay, so how we can get this dy by dx is the next question. Is there this what is this Shabir Saab? Is he there? Shabir Saab वहां पर है? CR Shabir Saab कोई है वहां पर? Anybody? Just want to know how much time I have left. 15 minutes more. Yeah. Someone is raising hand. Can you come on the mic and unmute because it is muted. Your voice is not coming.
Sir, actually in the class है fluid mechanics की.
कितने बजे?
12:30 तक.
Okay, we will finish by 11. Okay, by 12:30 से, हाँ?
11:30 to 12:30.
11:30 to 12:30 वो क्लास है. सर आ गए क्या? सर आ गए?
हाँ सर वेट कर रहे हैं.
Okay, okay. This is just I will make some points what we are going to do in the next class and I will be done. Okay. So I think now you have got some. So this was just an introductory class. You need not to be terrified with what mathematics and other I was doing. It is not like to terrify you. Only thing I want to mention is that in the coming class, we will be dealing with the very basic examples like projectile motion, spring mass system. Okay, a particle in a straight line motion. We will get the equations of the motion. We will code them in the MATLAB. So in next class, I want all of you to have learned some MATLAB things, okay? So that we can, I will also give maybe 1 or 2 lectures on this MATLAB, how we use it, but you should also put your efforts to know something about the MATLAB because whole purpose is to code things, okay? Rest of the theory, others are will handle, okay? I will also provide some theory and other stuff, but the major thing is I will focus on the coding part, okay? So get to the, if anybody among you doesn't have the laptop, share your friend's laptop with you. I know that your friend may be enough generous that he will give you laptop for coding purpose if he is fed up with the movies. Okay, so with this, I think I am done for today. But if anybody have any question related to this course and today's lecture, anything, you can ask freely. Raise your. Okay, you are done. Yeah. Shall we call it a day? Okay.
Okay, sir.
Okay. Thank you. Thank you.
Thank you, sir. Allah Hafiz.
Loves.